Welcome everybody. Let me introduce myself. I am Dr. Marshall. I'm the chair of the Aerospace Engineering Department. This is my 6th year as chair. Thanks for taking some time out of your Saturday to come and hear a little bit more about our program, and congratulations on making it this far, and hopefully you'll choose Cal Poly as your destination for your aerospace engineering education. All right, so Kendra, I think you have control. Okay.
I do, and now when I want it to move, it's not moving.
Just hit whatever button you're hitting before when it was moving.
Yeah.
All right. The Aero faculty and staff. We value diversity in our community here, and we value it not only in the students that we hope to bring in, but also in the faculty that we have, as well as the staff that we have. So the department has currently 9 tenured and tenure track faculty members. We just hired 2 that started a couple weeks ago. That is Dr. Hiremath, he's the bottom center, and Dr. Torres, who's the upper right in that 3x2. And this is some of the other faculty members in the department. We have around 3 or 4, depending on the year, lecturers as well, who help us teach our curriculum and help advise students and do a lot of other great work and share their engineering knowledge with the students. And we have Kendra, who's the office manager and basically makes this place run. And then we have Cody, who's our technician, who gets all of our equipment working and keeps it working, and does everything that we need to get done for our labs. All right, and so I think that there are a few people here. So Kendra, do you want to introduce yourself to start off?
Oh, sure. I just turned off. Hi, I'm Kendra, and I work in the Aero department office. So when we're back on campus in fall, I can't wait till I get to meet you. Or so this is where you'll come if you have any questions about anything. I'm happy to help you. And my office, if you're there, you'll see is the main office where all the other faculty are. So yeah, hope you choose Cal Poly. You'll love it.
All right. And then we have Dr. Four.
Good afternoon, everybody. Yes, I'm Dr. Four. Not sure what to say about myself because I'm usually not the first to speak. But I'm one of the instructors you will have most likely in your junior or senior years, either on topics either related to systems engineering or spacecraft design. I'm on the bottom right on this slide.
And what's your area of interest?
Oh, my area of interest. There are many, but let's say small satellites, anything related to small satellites. So that's pretty much everything and nothing. Sometimes, as we say, I also run the CubeSat laboratory here on campus, and that will be presented by some of my students later on. So you might have me earlier than your junior year if you join the CubeSat laboratory. Thanks, David.
Thanks. And then we have Dr. Iskold. Sorry, new glasses.
Hey, yeah, my name is Paul Iskold. I'm on the top center picture. My areas of interest are airplane design, so pretty much everything that has airplane related, I'm interested on. And as you see on this picture, and the reason that I don't have my camera is because I like to be around airplanes. So I'm driving out to the airport, and if you come to Cal Poly and we get to work together, I'm pretty sure you're gonna be involved with airplanes with me as well. So yeah, that's pretty much what I do. Thank you, Dave.
All right, and then we have one of our lecturers and a former, well, not former student, he's actually an alum of Aero, Ed Burnett.
Turn my video on as well. Yes, my name's Ed Burnett. Graduated from the program in 1983, and I've been serving with the Industrial Advisory Board for a little over 10 years now. And I've just tried to support Cal Poly however I can. When the department needed some help with the lecture, I volunteered.
All right. All right. So,
Oh, I was gonna say my student assistant Monty's here too.
oh, yeah, Marty, why don't you introduce yourself?
Hi, yeah, so I'm the student assistant. I'm Marilena Madi, and I just help process paperwork. I help Kendra. I'm going to be graduating this quarter, but typically you would see my coworker and I sit at the front desk. We help you answer questions and process paperwork. And in the meantime, if you need any help, feel free to email the Aero account, and I'll probably get back to you.
Probably.
Probably. Yeah, she's really good.
I will get back to you, but it will most likely be me and not my coworker.
All right, thanks, Marty. And yeah, unfortunately, yeah, we can't stop her from graduating, so she will be leaving us.
Yeah.
All right. So so a little bit of just background information about the program, and a lot of the questions that I'm asked when individual students come and want to find out a bit more about the program. So in our program, there are a lot of research opportunities that where you can learn a lot outside of the classroom, where you apply some of the knowledge that you've learned in class, and you can apply it to some practical real world experience. And so some of those are CubeSat, Prove, the Autonomous Flight Lab, and we have some students that will be talking about those activities and many others later on. So another highlight of our program is that we're one of the only undergraduate programs in the country that has an actual space environments lab, where students get to not just learn from the textbook about how the upper atmosphere and how space affects materials and satellites, but we also have a lab class where students get to see those effects and get to participate in some experiments on measuring how much outgassing happens in a vacuum when different materials are put into a low pressure environment. So a lot of really cool activities that go on in a lot of our labs, and that's just one unique example that we have here. This is another question that's asked a lot is what kind of what are some of the employers that Cal Poly Aero students end up going to. And so we have a lot of connections with Lockheed Martin, Boeing, NASA, Northrop Grumman, a lot of the aerospace companies, especially out here on the West Coast. Raytheon, I don't want to forget them, as well as a lot of startup companies that are looking to hire sharp engineers. And so just about every student who graduates within 6 months is either in graduate school or has a job in their applying their aerospace engineering degree. So right now, in the past several years, and even this year, our students are having success, finding jobs in the job market. The latest salary survey that we have shows that undergraduates graduate with a salary of $77,000 a year, and graduate students $87,000 a year.
Oh,
All right. So the life of an Aero student. So, like I said, there's a lot of opportunities to work both outside the classroom and inside the classroom. So these are just some of the different examples of activities that the students have participated in. Some of them are directly related to classroom activities. Like, for instance, the upper left image, that was from a few years ago when the design class took a trip to look at some aircraft for Cal Fire. And I believe that's the year that they were tasked with trying to design a aircraft for fire suppression and fire monitoring activities. The upper center picture is it's a test in one of our structures labs. And on top of the class activities, there's also extracurricular activities. Extracurricular activities. So the bottom left figure there, that's one of the research airplanes that we have in the Autonomous Flight Lab. And the upper right, that is, I believe, our CPSSS, our Cal Poly Space Systems club, showing one of the rockets that they are working on.
yeah, they were in a competition in Florida. They did the Alka-Seltzer or something.
Oh, the Alka-Seltzer contest, yeah, where they had to try and design a rocket that would be powered by Alka-Seltzer.
Yeah.
And then the bottom right is an aircraft that the department has and flies. The pilot is actually the one whose hands are currently in that picture, not on the stick. And we take students up to do tests on some inertial navigation equipment that they design in one of our classes. We also have some organized events that are pretty fun. The first year students are here. They participate in a class that gets them working in teams, gets them to know their fellow classmates. And there are two competitions, air quotes, that the class participates in. One is a rocket competition where they launch small model rockets, and they have a payload, and they have to ensure the payload survives the trajectory. And that usually happens on a Saturday when it's parents' weekend. So a lot of parents that are in the area will come by and watch the fun activity and see all the different designs that don't go as straight as the students had hoped, like this one. We also have what we call our design symposium, which is the where our graduating students get to present their final designs in either aircraft or spacecraft that they've been working on all year. And so we invite industry members to come and participate in that final design review, provide good feedback. And there's also a poster session where the industry members and the public can come and ask particular questions about the different design components that are associated with the system. And then we also host a CubeSat workshop every spring that brings in people from around the world who are working on CubeSats and developing, the next generation of CubeSats. We also have, a bunch of events that our clubs organize. And, an example would be, or then also clubs can go on competitions like the Alka-Seltzer with contest with CPSSS, DBF, our Design Build Fly Club, which is a pretty active club in our program here. They have a contest where they go and can fly their the aircraft that they design every year, and that's what the bottom right picture is. Okay, and then so here, just a list of the student organizations. Once you get here, there's actually several opportunities for you all to get to know more about these student organizations. We have representatives that come during the week before the fall quarter starts, and we call that the week of welcome, or Wow Week. And so we have an opportunity for those clubs to come and present to the new students. And there's also what they call a club showcase event. That's where all the clubs on campus can put a booth together, and then the new students can just kind of tour all the different activities and see the what activities that there are even outside of aerospace that they can participate in. All right, so just a brief overview of our curriculum. We expect 4 years to be how long it's going to take for you to get out. Some students like the area so much they'll stick around for a few extra years and get a master's degree. But here's kind of like a basic breakdown of what the 4 years are. So the first year is really about developing the fundamental math and science skills that are needed for engineering. So it's a lot of calculus and linear algebra and physics and chemistry, and it's just basically, there's a lot of analysis work that you need to do as an engineer, and to do that work, you need to get a really strong preparation in those fundamentals. On the department side, we have that class in the fall of your first year, and that class is really starting to get everyone to learn how to work effectively in a team environment, how to make sure that everyone's input is considered and everyone's input is heard, and everyone participates in the design process, so that you have the best the best design, the best synthesis of everybody's ideas that you can get. The second year is then it's more focused on applying the math and science skills to fundamental engineering. That's going to be the basis for aerospace. So aerospace builds on a lot of other disciplines, and so before you get into the meat of the aerospace curriculum, there's some fundamental engineering skills like electroengineering. There's a lot of strength in materials and mechanics of materials that you need to get familiar with, fluids and statics, dynamics. Those kinds of analysis are common to a lot of different engineering disciplines. And then on the aerospace side, the second year is where then we start introducing things like systems engineering, some fundamentals about experimentation and data acquisition systems, and then design methodologies. So this is where we're prepping you for the classes to come. Our third year is where you really start hitting aerospace content. So this is when you have to decide whether you want to go the aeronautics or astronautics concentration. And you've had some classes beforehand that kind of give you what the flavor of the two different ones are. If you go on the aeronautics concentration, then you're going to be focusing on things like aerodynamics, aircraft dynamics and controls, aircraft propulsion. And on the astronautics side, It's going to be orbital mechanics, spacecraft dynamics and controls, spacecraft electrical systems, propulsion again, but this time with the focus on spacecraft propulsion. So there's a lot of unique aspects to the aeronautics and the astronautics curriculum. There also are some common topics that we provide, and dynamics and controls is one, structural analysis, fluids is another, systems engineering is a really important component to all facets of aerospace engineering. So we also cover those topics in the third year, and then the last year is about applying the discipline knowledge that you've gained to do a year-long design activity. That design activity is team-based, and it will last for the whole year. You'll go through several different design reviews. You'll get feedback from a lot of different reviewers. So the classes will, in the past, they've traveled to different industry sites and have gotten participation in their design reviews from engineers from different companies. This is also the time where you can develop additional depth of knowledge in certain technical areas. So if you're really interested in orbital mechanics, then we have some more orbital mechanics classes that you can take to get a better depth of knowledge in certain technical areas. And that's basically our curriculum.
Yeah, Nandish just joined. I saw is here. We missed
Oh, Nandish,
him. Maybe
would you like to introduce yourself?
can you turn your video on and say hi.
Hello. Yes. Yeah, I recently joined Cal Poly as an assistant professor. Yes, that's me.
So what's your area of interest?
My area of interest is primarily experimental aerodynamics. And this quarter, I'm teaching Aero 307, which is into low speed wind tunnel testing. And going forward, I'll be dealing more into experimental aerodynamics aspects, going beyond low speed aspects. Looking forward to re-entry flight physics. Yeah.
Okay, great. All right. So with that, then then we have aero clubs and IRAs and aero organizations that are going to give you a quick presentation.
All right, so I just did them alphabetical. So AIAA, if they have representation here, I want to start. Nobody here.
Oh,
We're starting off good.
oh my goodness. I can talk about
I can,
AIAA. Oh,
This is Ed. I can talk to AIAA.
yeah, Ed, why don't you give it a whirl?
So the American Institute of Aeronautics and Astronautics is basically the professional organization that services the aerospace community, has several very large forums a year where papers are presented, different talks on new subjects coming out are done, and Cal Poly has in the past had regional conferences where students basically are presenting papers with other students from other universities in the Western United States. It's a very large concern and helps support the universities through things such as ABET accreditation. The AIAA is the sponsor to ABET for aerospace programs. So they provide the accreditation teams that go out around the country. So it's a great organization. I joined in 1982 and am still a member, and have reached the position of fellow in the organization.
Thanks, Ed. All right, ADCC. I know John's here.
All right, guys. So I am the Vice President of the Aircraft Design and Construction Club. So to give you guys a bit of an overview of what we do, our goal is to take on a couple projects every year and work them from design, manufacturing, and then flying them. So the professor we work with is Dr. Iscold. We always love seeing new students come and help us out, especially helping you guys fill that gap between Aero 121 and continuing to be involved with aircraft projects. So we're going to kind of go over some of the projects that we have as continuing projects, some projects we've worked on in the past, and some stuff we're working on right now. So I'm going to pass that over to John to start us off.
Hey there, guys. My name is John Kroska. I'm an ADCC officer. I'm also a fourth-year aeronautics mate concentration in aerospace engineering. And I wanted to talk to you guys first about our intro to quad and fixed wing projects. For newer students at Cal Poly, they're really great projects to get involved in because they teach you a lot of the fundamentals about engineering and design. And then between fall, winter, and spring, fall will be our design phase usually. Winter is a lot of construction. And then in the spring, you actually get to fly the projects that you end up making. And so we're really excited for whenever new students get to come in and work on those and then fly them, maybe crash them, who knows. But that kind of also ties into our drone racing that we're trying to get started this next year, which will actually feature, hopefully, a lot of these quadcopters that are going to be built by you new students, hopefully. And then we'll get to race each other both in person and then over simulators as practice beforehand. And then I'm going to pass it off now to our other officer member here, whose name is Matt. He'll be talking to you about some of our other projects.
Hey guys, yeah, my name is Matt, and one of the other projects that we're really excited about and working a lot on is Project Zenith, which is a low altitude solar glider, a solar aircraft, I should say, aiming to fly continuously for 24 hours. And to give you an idea of scale, it will have a wingspan of about 19 feet, carry about 100, or sorry, that'd be a lot, carry about 11 pounds of batteries, and have about 90 solar panels on board. Currently, we've built a half-scale model as a technology testing platform, which admittedly we've crashed a few times, but we're pushing forward with the preliminary designs of the full-scale aircraft. I'll pass it off to David again for our last project.
Yeah, so the last project I want to talk about is Skyper. So with that project, that was a project that we wanted to, no bars, figure out how to fly an aircraft 200 miles an hour, unmanned, I guess. So we went through a number of design phases, did aerodynamic analysis, some CFD on that, sizing and propulsion, and it's been an interesting project to work on. It's a kind of, as you can see, a flying wing that would be implementing not only, doing the analysis and aerodynamic side, but also looking at doing kind of more advanced composite manufacturing with a monocoque airframe. It's been a fun project to work on, and we'll be possibly looking at getting that manufacturing this once we're all able to get back into the club space. So yeah, thanks for listening to us. If you want to reach out to us, that's our email that you can see. We have, if you want to join now, send us an email, that email, and we have meetings every Saturday. So feel free to reach out.
Great. David, should we hold the questions till the end if people have the questions for the clubs, or what do you think?
If you've got questions for the clubs, you can ask them after they're done presenting. So if there are any questions for ADCC, then you can ask now.
Does anybody have a question they want to ask them?
Sure, I'll go ahead. You said that you were looking to try to get drone racing started on campus. Is there already a contingent of RC pilots around?
So we actually have a very large amount of people interested in hobbyist type racing.
Mm-hmm.
What we're trying to do is push that a step further and get the equipment to set up race tracks here on campus, and then get I think
trying to work towards like multi-GP style.
Yes, okay. Exactly. Currently, we use the Velocidrone platform to do simulator racing when we can't be in person, but then hopefully in the fall we'll be able to get that set up.
Very fun. Can I go one further and ask, is there a contingent of glider pilots on campus? RC, of course.
Glider, yes. We've had a couple meetings. I don't know if you saw the couple slides back. There's the flying field that we have that's over by Cuesta College, and
Okay.
a bunch of us that, you know, even outside of the club will sometimes go meet there and just kind of have fun flying days on the weekends.
All right, sounds great. I look forward to that in the coming years.
Thanks.
And if you're a RC glider pilot, you probably know the name Joe Wirtz. He's a Cal Poly alumni, I think 84 or 85.
Okay, any other questions before we move on? All right, AWKF League.
So on the note of gliders, we'll go to the AWKF League Glider Club.
Yay.
So let me just explain AWKF League, the name. It's a German word that means academic flying club. And throughout Germany, at many of their engineering universities, they have these academic flying clubs that do a lot of different engineering as well as flying related activities. Anyway, AWKF League is sort of to try and make that our own in the US. It's one of the first glider clubs at a university. And basically we aim to teach students here at Cal Poly not only about the actual act of how to fly a glider, but also about the engineering that goes with it. So, you know, how is a glider built? How do the composites work? How do the controls work? How do the aerodynamics work? So it's sort of a mix of both learning how to fly as well as learning a lot about how the actual airplane and the engineering goes into it. We also have our own simulator that is available to all students. Obviously, COVID has made that a little bit hard, but once COVID restrictions are lifted, we're excited to get a lot of students flying that simulator. And that's just another good way for people to supplement their flight training. We fly, although it's not associated with the university, we do encourage students to come fly as well at an airport out in the Central Valley. And so that's part of what we help students do as well. And then generally just try to foster a good aviation community and teach students sort of just about how amazing flying and aviation in general is. So yeah, if there's any questions, I'd love to answer them. And you can also check out our website at akaslow.com or give us an email if you want. The email's right there as well.
Sorry, I was on mute. Will, somebody wants to know the city where you go flying. Is it Crystal, California City?
Say it again.
Crystal, California City?
No, we don't fly out of Crystal. We fly, some of our students fly with the Central California Soaring Association, which is in Avenal, California. It's about an hour and 20 minutes from here.
Thanks.
Yep.
Any other questions or anybody? Okay. Thanks, Will.
Mm-hmm.
Right, CP Intercept.
Hello, everyone. I'm Jake, and I'm the Vice President of CP Intercept this school year. I'm also a third-year aerospace engineering student concentrating in astronautics. I brought one of my fellow officers, John, to help talk about our club. So, John, if you want to introduce yourself, go ahead.
Hey, I'm John. I'm an aerospace physics double major. I'm a fourth year going in astronautics.
Sweet. So yeah, CP Intercept actually stands for Cal Poly Interdisciplinary Satellite Engineering Project. We are a club that was gifted parts and plans for a Boeing HS 376 communications satellite back in 2002. We've been working to assemble this two-section spacecraft in a very hands-on environment that fosters the Cal Poly Learn by Doing philosophy. And currently we're working a lot on 3D modeling with the virtual format. So we've been using SolidWorks PDM to collaboratively model our spacecraft throughout the pandemic. And the goal of that is really to gain a better understanding of the satellite and its components. We have also been making the most of this year's virtual format by hosting guest speakers and organizing aerospace trivia nights, which have been super fun. And then I'll go ahead and toss it over to John, who will talk a little bit more about our club's current events and future plans.
Yeah, so Jake covered a lot of what we're doing right now, at least in terms of current events. We've been hosting some speakers on ranges of topics from like space policy all the way out to the three-body problem and like black holes and astrophysics. That was a fun talk. And we do these bi-weekly trivia nights where we have a professor host and give random questions to random teams of aerospace students, try and foster some social interaction during the pandemic. I'm also the horizontal shelf lead for this project, and that is not really something that's super visual on this craft on the right. But near the top where the payload sits, what that's on top of, that's me. Yeah. So far, actually, we have a big chunk of this satellite done. Almost the entire lower half of it is built and sitting in our lab right now. We just went in this morning to pick up some more plans to pass out to do some solid modeling on. But yeah, hopefully we got some good plans going, and when we get back in person in the fall, we can get back to manufacturing. Be excited for you to join us.
Okay, any questions for them?
How big is that satellite?
Oh, let's see. 2.5 meters, I want to say. Yeah. So like in, American units, 8 feet, maybe.
I was gonna say, in real units, what is that? 8 feet? Okay.
Okay, let's see who's next. We've got CPSS.
All right. Hey, everybody. We're CPSS, and my name is Kanan Krimley. I'm the Vice President of Cal Poly Space Systems, and I'm here along with Miles to talk to you a little bit about CPSS. So first of all, what is CPSS? We're an experimental rocketry club here on campus. And if you don't know what that means, that means we basically, we build rockets, we design, manufacture, and test all of our rockets, and we make many different types of rockets. Our main rocket right now is the 30,000 foot category hybrid rocket. So this combines a mixture of a solid fuel and a liquid propellant in order to make this 30,000 foot category rocket. And that's the picture that you can see on the top left-hand side. Because we do so many different types of rockets, we have many different disciplines in our club. We have everything from aerodynamics to structures to propulsion and much more. So we have many different types of disciplines that can help you get involved in a lot of different types of the aerospace field. And I hope I can see you guys all next year in person, and I'll pass it off to Miles to talk a little bit about the competitions that we go to.
Hey guys, I'm Miles. As Kanan mentioned, yeah, the rockets are really an interdisciplinary project because it is such a large and comprehensive system that we have to design and build. And we design these rockets for different competitions. The primary one that we're working towards right now is the Intercollegiate Rocket Engineering Competition, or IREC. We also regularly go out to the Friends of Amateur Rocketry in the Mojave Desert to do launches out there. And we usually compete in 30,000 foot class competition, which means that our rocket is aiming to hit right at 30,000 feet at its apogee before it comes down, and we recover it under parachutes. We also do some other outreach events and educational things, like doing little like bottle rockets with pressurized water out at elementary schools, or as Kendra mentioned earlier, we do some of the Alpha Rocket competition for the past few years, to other things. But yeah, it's a really great club. Hope you guys can come out and build some rockets with us.
All right, questions for CPSS? Oh, someone, let me check them. Oh, okay. Quiet group here. All right, let's see who's next. Okay, CubeSat.
Hello, my name's Madison Lytle, and I'm a second-year aerospace engineering and math student here at Cal Poly. And I'm also an incoming lab manager and one of the project managers for the Cal Poly CubeSat lab, which you will sometimes hear is referred to as PolySat when you're on campus. And so our lab is an interdisciplinary research laboratory, and we build and operate small satellites, specifically CubeSats, which were created actually in a collaboration between Cal Poly and Stanford. And so we get to do a lot of hands-on learning with actual space hardware and space systems, which isn't something that you often get experience with in your undergrad. So it's really nice to have the opportunity to make something that is going to end up going into space and see all the parts of the design process, from kind of making an idea to building an actual satellite. And I'm also here with George
Hi
from
guys,
Lab.
I am George Kavijian. I'm a first year aerospace engineering student here at Cal Poly, and I am part of the Aero team at CubeSat Lab. I'd say CubeSat Lab is one of those very special clubs where half club, half a full-fledged industry organization, where we delve straight into into many projects where we work with industry very closely. One of our recent projects, XCube, we're working with NASA on, and will hopefully go up in the air soon. Since I am a first year, if you guys have any questions about what it's like being a first year on Cal Poly CubeSat Labs team, be sure to let me know in the chat, and I will update you guys. Yeah, and we also have our Dr. Four, which is who is our lab director here as well. So if you guys have any questions for any of us, be sure to let us know.
Yeah, she put some information in the chat. Sorry, the slide advanced before you guys were done. I didn't mean to do that. Yeah, so are there any questions for CubeSat? Okay, we'll move on then. Thanks, guys. Next is Design, Build, Fly, DBF.
Hey guys, I'm Laird. I'm the lead engineer for Design, Build, Fly this year. And I'm a third-year aero student. I'm actually on astronautics concentration, but this is an aeronautics club. We compete in an RC aircraft competition that AWA puts on every year. And we just go through the whole design process for this RC airplane to meet the competition requirements. And so it's a new competition every year. So you kind of get to come in on the ground floor and help us work through that design process. And next year we're going to be being able to do like manufacturing and testing and flight testing and stuff like that, which is going to be really fun. So I hope to see you guys next year.
Anybody have any questions?
Oh, also, I will put our email in the chat. I don't know why it's not in the slide. I should have done that.
That's great. All right. Oh, is there? Okay. All right. Prove.
Hey everyone, so we're the Prototype Vehicles Laboratory here at Proof. I'm Kellen Barsley, one of the project managers, and I also work on the business team and the high voltage team for our current project, Mila. So here at Proof, we're a fully student-run organization, which means our projects are built from the ground up and designed entirely by students, aside from some oversight from our advisor, Dr. Iskold. All of our projects are designed to be record-setting vehicles based on renewable energy, so solar power, gravity-powered, electric-powered vehicles. And we make sure to try to foster a professional environment using softwares such as NX and Microsoft Teams, just to keep a safe space for all our members. So I'm going to go ahead and pass it off to Caleb, who will talk about our current project, Mila.
Hi everyone, my name is Caleb Erlenborn. I'm a third year here at Cal Poly, and I specialize in mechanical systems and structural design and analysis at Prove Lab. Our current project, Mila, the goal is to break the record for the farthest distance traveled by an electric car on a single charge, which currently is 999.5 miles. So we would like to get over 1,000 miles and actually over 1,200 miles just to blow that record out of the gates. We're currently working in finishing the design of the car and preparing for the initial stages of manufacturing. Last year, we actually welded the steel chassis, which you can see in the bottom left photo there. And like Helen mentioned earlier, we utilize the industry leading CAD software, Siemens NX, which is really great to get some hands-on experience in that software and prepares you really well for like internships. And we love being able to apply our developing engineering knowledge to this pretty ambitious project. And I found it really enjoyable. I'm gonna hand it off to Shay now.
Hey everyone, my name is Shay. I'm a third-year aerospace engineering student concentrating in aeronautics. In Prove Lab, I'm one of the program managers, and I'm also the manufacturing and integration lead. So I'm just going to talk a little bit about another one of our projects. So Caleb talked about Mila, which is that image of the sports car looking thing in the on the right column middle. Dawn was our previous project, and it's a high-speed solar car, which was designed to break the solar land speed record of about 57 miles per hour. Now, that might not seem very fast, but you just have to consider that this car must travel without a battery and powered solely on the sun's energy. And taking that into consideration, you can see how big of an engineering challenge creating Dawn was. It was Prove Lab's first project, and it's really done a lot to build up our reputation as a innovative and inspiring student organization. Pictures of Dawn are at the top right and bottom right. Yeah, I'll hand it back to Kellen.
Yeah, so as you can see there, we have our website, provelab.org, as well as our email, provelab@calpoly.edu. If you have any more questions, or if you have interest in joining the club in the fall, you can go on there and we'll have an interest form. If you fill out the interest form, then we'll put you on our email list for when we start recruitment in the fall, and you can go ahead and try and join. Does anyone have any questions? Right.
All right, thanks, Kellen. That concludes clubs and IROs. David?
All right, so clearly we have a wide variety of aerospace opportunities available for students to apply their knowledge outside of the classroom, and that is one of the unique things about Cal Poly, that we work pretty hard to provide these kinds of opportunities for students to do these hands-on activities, so they can learn how the actual aerospace engineering and how works, and how to use tools that are representative of what they'll be seeing in industry, to be a productive engineer. So to close out the presentation, I just want to once again highlight the fact that we're looking forward to having you all show up here in the fall. And if you've got any questions for me about the department, or if you want to ask about some of the faculty members and what they're doing, then by all means, fire away.
Okay, we have one, somebody's asking if you could talk about study abroad as an Aero student.
Yeah, so there's, I would say the first and second year is where I would think most of the Aero students actually would be participating in study abroad, because once you get into the third year and beyond, there aren't very many there really aren't any opportunities to skip a quarter and come back and still be on time to graduate in 4 years. So if you wanted to modify your education plan, then you could graduate after 5 years and work in the study abroad later on. But students will typically do a study abroad program. If they're going to do it, they'll do it their first or second year in Aero, and they'll take some of their GE courses and some of their service courses at that location. We do have, the university has some collaborations with other universities that are that have some aerospace tie-ins. There's a university in Munich that we have an affiliation with, and there's also a university in Japan that we have a relationship with.
If you also have specific questions for an Aero student, current Aero student, since we have some here, you can shoot those up too. I'm sure they'd be happy to answer any of those as well. So just pop them in the chat or speak up.
Are you guys in like multiple clubs, or do you primarily focus on like one or two?
Who would like to take that?
So I know several students that do participate in multiple clubs. A lot of the times clubs will meet on the weekend. So it's just a lot about time management and making sure that you're fitting in enough time to get your homework done, as well as take care of the extracurriculars that you're involved in. But certain clubs like AIAA and ADCC have had overlapping members in years past and currently still. So it's definitely possible. It's just kind of a matter of time management and interest.
Yeah, I'd like to second that, what John said. I think one thing you'll find pretty soon is like the capacity of like how much time you have to spend on certain things. I at least have quickly learned where my limits are, and it's really a matter of just organizing your schedule and figuring out how much time you want to invest in different areas of your curriculum and education. So in Peru, we've also seen members who are members of multiple clubs. So it's definitely doable.
Okay. As a new freshman with little experience, what jobs are you given when you join a club?
George, can you take this one since you're a first year and you recently joined the CubeSat lab?
Yes, of course. So I think whenever you do go into any club, you need to recognize the skill set that you do have. And generally, I think this goes for all clubs as well, is whatever you put into it is what you can get out of the club. If you do tend to veer towards a more of a hands-on portion of the club, you will, and for most people, there's always going to be a learning curve, and you have to be here to learn. So involve yourself, and as you involve yourself, you will learn and you will grow to those heights. So don't be afraid to try something. Don't be afraid to put yourself in a situation where you may think that you don't have the experience, because you will get the experience as you do and as you work through that club.
Thank you. Is it easy for students to build their own projects using the labs, or do they have to be a part of a club to do that?
So it really depends on the lab and the activity that the student is wanting to do. For the most part, though, I would say that the activity probably needs to happen in relation to a club, or be supervised by a faculty member, because frankly, a lot of what we do is dangerous. All right, CPSSS is a club that has to have safety at the forefront, because they're building controlled bombs. We have a lot of equipment and a lot of material that is just, that needs supervision. So again, depending on what that activity is, it's, it might or might not be able to be done on your own. Cal Poly has, the engineering department has a couple of different shops where once you're trained, and we go through the training with students the fall of their freshman year. Once you're trained, then you can go use the shops when they're open to do some manufacturing. But again, those are going to be supervised by shop technicians.
We also have a question from a little earlier in the chat that asks, what does your work-school balance look like?
All right, student.
Go ahead and get this one too. I have to say, your work-school balance is then once again, it's all what you how you plan yourself out and your schedule out. There are more clubs that obviously take more time, and clubs, for example, such as ADCC, allow for more individualized schedule and a schedule that allows you to work around a more flexible time frame. And so being able to, obviously you don't want to overload yourself, and as you progress throughout the years, you'll get a good feel for how much you can take on, how many clubs you will be able to do, and just how much you want to involve yourself outside of classes.
We also have a question. When are we able to connect with advisors to figure out fall class schedules? And is there a dedicated Aero advisor?
Yeah, that's a good set of questions. So there is a dedicated advisor for Aero students, and that's Dr. Abercrombie. And she has specific advising hours during the academic year where you can schedule an appointment with her and talk about whatever particular questions you might have. Sometimes students will schedule a meeting with me, and will ask me some advising questions as well. I'll be honest with you, I'm not as well versed on a lot of the intricacies associated with degree progress, but there certainly are a lot of issues that I can help with, and I'm happy to help with. So depending on if you're a transfer student versus your first-time freshman, when you're connected with advisors will be slightly different. For transfer students, there is a time during the summer period where the transfer students come and work with the engineering advising program to build their fall schedule. And at that point, we usually meet with the students, myself as well as Dr. Abercrombie. Will meet with those students and answer any questions that they have. For first-time freshmen, I believe that happens where during the WOW week that students get registering for the classes, and I could be wrong on that.
First-time freshmen are blocked into your schedule, so the university, the registrar's office will block you into a schedule with your required classes, so you'll probably be enrolled in Aero 121, which is like the first Aero class you take, a GE maybe like comms, and then maybe one of your math classes that you have to take or physics classes. But those things get blocked. You should be getting a survey sometime, I think in May, typically, where you like fill out your priorities of like classes you have already taken or would like to take. And then there's also a question in the chat. I don't know if there are any transfer students here, but if you can talk about adjusting the coursework to Cal Poly compared to the other university you may have been at previously.
Sure, yeah, I can take that one. So I think the coursework is easily adjustable. I think it's comparable. Things just happen faster. That's the main difference. One other big difference about university versus community college in my experience is just that the level of distractions here. Like you saw, there's so many amazing clubs, and as an incoming student, it can be very easy to have very big eyes and be very ambitious with different things you get involved with. So that's also another thing to watch out for. But I think the level of support that you have academically with your professors and your advisors is definitely sufficient for you to be able to adjust well.
And just to add to that, you know, our general experience with transfer students is that transfer students will adjust pretty well to the pace of the quarter system, and they've been well prepared in their prior years at their other institutions, and have a bit more. They've developed study skills that they can utilize and be successful with. One of the things that first time freshmen have some troubles with adjusting to is the fact that there may not be as many solid study skills that have been developed through just high school, because you know everyone who comes here is going to be a sharp student, and at some point you're going to reach a point where your smartness is not enough to get you through the class, and you're going to have to work hard on it, and that comes as a rather large transition for some students to deal with. So building up those study skills is an important thing for everyone. I think those are all the questions that I was able to see as they flew by as well. Did we miss any, or are there any other questions that you all have?
Regarding the clubs, when can we start when can we start actually looking to apply to some of the clubs if we're already going to go to Cal Poly in the fall?
I guess I'll take this, and clubs, y'all can correct me when I'm wrong. So typically there's that club showcase where the clubs are available to start taking or start organizing the student lists of Cal Poly email addresses that they can communicate to prospective club members. And so they may be able to actually accommodate students who have an interest earlier than that, but I think a lot of the clubs kind of set their recruitment schedule based on the start of the fall quarter and the club showcase that happens.
I can add on that. So like Dr. Marshall said, there are numerous organized events for getting into clubs. And I can speak for my club and probably some other ones, but if you have our email, it definitely doesn't hurt to just send us an email expressing your interest. And for us in particular at Prove Lab, we make sure to take note of anyone who does that, and we put you on a list, and we contact you when our next recruitment cycle comes up. So that would be a good first start that I would recommend.
Thank you.
Yeah, and I think that some clubs you can get started on even right now. Like if you contact ADCCC, we can definitely get you plugged into projects immediately if you would like to. So.
We also have another question in the chat. If there are any students who had difficulty choosing a concentration, how did you end up choosing your concentration?
So I can maybe jump in here, unless there's an actual student who was in that situation. Because that's one of the things that I'll get asked by students, and when they'll come to meet with me is they'll ask about, well, I like I like this part about aeronautics and this part about astronautics. We do have a couple of classes before you have to make the choice that are intended to show you, in broad scale, what the differences are between the two different disciplines. The other thing to focus on is that you're still going to be getting an aerospace degree, and looking at your career trajectory going forward, you may not be entirely in one side versus the other side. We have a lot of alumni who start off on the aircraft trajectory, but then transition over to spacecraft at some point, and then switch over maybe again. So it's not as critical of a choice as sometimes students feel like they're making. And so one of the things to think about is the fact that you're not actually setting yourself up for just a solitary career path going forward. You're going to learn a lot of the same concepts in going in either track that will help you well into the future. And then I think probably one of the other main kind of deciding factors is, of the classes that they've had so far, what was the material that that they found most intriguing, and then that can kind of help them adjust or decide to go one way or the other. But there are also students, and then I don't remember who it was, I'm sorry, but there's students who choose one track, but then they do a lot of extracurricular activities in the other track. So it was DBF that has a astronautics person, right? Are they still here? No, maybe they dropped off. So there are students who actually will focus their extracurricular activities on, let's say, spacecraft, but their curriculum will be the aeronautics track. So
This is Ed Burnett. After my 38 years of industry experience, I had times when I would get called. I worked in an airplane-oriented company, but would get called in to help with our space brethren up in Sunnyvale. The actuators on a spacecraft are pretty close, at least on the launch vehicle, are very, very close to what's inside an airplane. The systems engineering of a satellite is very much the systems engineering of an aircraft. So you will walk both sides of it if you wish.
Okay.
all right. Yeah, well, I think that I'll stick around here for a few more minutes if people have any more questions. Otherwise, I appreciate you taking the time. Hopefully, we've answered some questions for you, and I know you've got a difficult decision coming up on where you're going to go, and hopefully, you give Cal Poly and the aerospace engineering program a strong consideration. And we look forward to seeing you in the fall.
I would also just like to throw in that I'm one of the people who help moderates our social media pages. And it's a really great thing to follow. You can see what all our clubs are doing, what our faculty are doing. And so I would advise everyone to follow us at Cal Poly Aero on Instagram and Twitter, and Cal Poly Aero Department on Facebook.
All right. So unless you've got anything else, enjoy the rest of your day.
Thanks.
And thanks,
I guess
students. Yeah, thanks, students, for coming and talking about your organizations.
Yeah, thank you.
And sorry, I think I cut somebody off. Was somebody going to ask a question?
Oh, yeah, no, it's fine. I was contemplating asking this question. I figure I might as well. Having met a few different engineers working in industry and outside of it, there does seem to kind of be an ongoing debate of, is it better to work in pursuing work in aerospace? You know, whether or not it's more reasonable to pursue a degree in aerospace engineering or mechanical engineering, kind of as a function of the more generality of mechanical engineering, and the overarching interdisciplinary nature of pretty much all of the projects that are going on around here. Can anyone reflect on kind of the why aerospace argument there? But also thank you to all the club presenters. This has been a really wonderful presentation. And I'm more confident in my decision to choose Cal Poly just for being here. So thank you very much.
Sure. Actually, you know, I haven't done the count, but I'm pretty sure that we have almost 50% of the department faculty have undergraduate degrees that are not aerospace degrees. Yeah. So, and me too. Mine is mechanical. So, you know, there certainly is a lot of overlap between many different disciplines and aerospace. I will tell you from my perspective, and my area is aerodynamics and computational fluid dynamics. I've also I have experience in spacecraft propulsion, and you know, I dabble in orbital mechanics. So you know, I don't want to call myself an expert. Dr. Abercrombie is the expert. But from my perspective, my undergraduate degree in mechanical engineering, it was broader than just aerospace. Okay, but it didn't provide me the depth of knowledge that I would have gotten if I would have gone to, you know, Cal Poly or an aerospace program. So things like aircraft controls, things like you know, like the structural analysis for aircraft and spacecraft, aircraft design, spacecraft design, all those very specific discipline topics you're probably not going to get at a mechanical engineering oriented university, because you know their program has to produce engineers that can work in HVAC, that can work in vibrations, that can work in all these other really neat and interesting disciplines, but just aren't the disciplines that aerospace engineers typically need. So to me, that's the real big difference. And if you know that you really want to be in aerospace engineering when you get out, then I don't really see a downside into sticking with aerospace, because on the flip side, we have a lot of aerospace engineers. I won't say a lot, but I know of many aerospace engineer graduates who went to Apple or went to Silicon Valley and you know are working at a startup, or you know they you know, have their own business in something totally in a different field than aerospace. So I think so I think that you know, if your passion is aerospace, there are jobs out there when you graduate. You're going to get a depth of knowledge here that probably won't be at a mechanical engineering program. And no disrespect to it, any mechanical engineering program. That's just the reality, and that's my experience.
It's a very persuasive answer. So thank you.
Ed Burnett here. I think I would add to that. In going through the Aero program, you're going to network much more with people in the aerospace industry than you would in a mechanical engineering program. So you're going to start building up that lexicon, the language of aerospace, a little bit more than you would in mechanical, including things like flying qualities that you won't find in mechanical engineering. And again, the networking is going to be one of the big things. That's, you know, AIAA, I really didn't mention it hard enough, but that club on campus is going to help you build your network outside of Cal Poly more than perhaps the other. So you're going to definitely want to do AIAA and other clubs.
I might be able to add a little bit of student perspective there as well. Whether going mechanical or aero, it kind of might depend on exactly what you want to do, because Cal Poly Aero is fantastic for learning how to design like systems and having a really good systems level thinking, and be able to look at like, okay, if I need to make a propulsion system for aircraft or spacecraft, you learn how to do that. You don't learn so much is like, how do you design the screws or the gears for that propulsion system, which is a lot more of what mechanical does. But like Dr. Marshall and Dr. Burnett were saying, you definitely get a really good breadth of knowledge and generalized knowledge of across the industry that you can apply to anywhere.
All right. Well, thank you, Dr. Marshall, Dr. Burnett, and Miles. All of those opinions are extremely persuasive, and hopefully I'll see you guys next year on campus.
Yeah.
Look forward to it. One of our new faculty joined us later than after we introduced. Leo's here. If you want to say hi, Leo, you can. And tell us anything about you or your interests, research, whatever.
Oh, thank you very much. First, I apologize for my delay. And unfortunately, I just saw some of the presentations from the clubs, but they were amazing, really. I have started as an associate professor here at Cal Poly just 3 weeks ago. So I'm a Brazilian, and I have worked with control theory for all my career up to so far. I have been a professor for 20 years, and I really love control theory, especially applied to aircrafts and spacecrafts. So I hope that some of you will fall in love for control theory too, and we will have a very nice time together, researching and developing control strategies, both for spacecrafts and aircrafts. And please, if you want to get in touch with me, let me just send my Cal Poly contact to you, and I will be very happy to interact with you. But my position now is that of someone that is understanding and actually every day I've got even more delighted with the fact that I'm here at Cal Poly, especially after seeing so much things that are being developed and are being done here. So it's a pretty amazing place, and I think that I'm really in a dream job. So I really need to. It will be very good if any of you want to work together on a research project related to control theory. So please, if you are interested, just get in touch.
Hi there, my name is Rafael. I'm a fourth year journalism transfer student with a minor in Spanish, and my pronouns are he, him, his. Thank you for watching the video. Please share any questions or comments you have down below in the comment section, and go ahead and click here to subscribe, and to watch more videos, click here. If you want to sign up for a virtual visit or talk to any student or staff members, check out our website. Link in the description. Thank you for watching.